Hello everyone and welcome back to another Universe Sandbox 2 video, and today we're actually going to do an idea which a lot of people wanted me to do for a while actually. So I remember it was way back when I made a video on about shrinking the solar system. People also told me to expand it, which I never ever got around to doing. So today I thought I'd go back and actually go and do it. Because a lot of people did want me to do it like a long time ago, and they still, I know there was a person who said the other day they wanted it, so yeah, I'm going to go ahead and do it because a lot of people want it, so your wish is my command, I guess. So yeah, let's do this. And also guys, many thanks to the likes on yesterday's video. We hit 20 likes in a day, that's pretty awesome. So yeah, many thanks. Let's see if we can beat it maybe, I don't know. Anyways, let's get into this. And also it's the 1st of August tomorrow, which means I've been on YouTube for a year now, so there'll be a special cool video coming out which should do or should be pretty good, and you should enjoy it. An updated version of a video I made a very long time ago last year. So yeah, if anyone can work it out, yeah, comment below if you know. So yeah, anyways, let's get into this. So I've actually forgotten how to do this. It's in, I think it's in powers. It should be here somewhere. Yeah, last time I did shrink, today we're going to expand. So we're in my custom solar system as usual. We'll put the orbits on so we can see everything. So we've got Planet 9, Sedna, all of my customized objects, all in the proper orbits, all loads of extra asteroid objects around here as well. So we're going to go and expand and press it once. So I think that makes increases, I don't know how much it increases it by, but now all of the objects are a little further away. So that should mean that objects like Earth, for instance, are going to start to cool down a bit. So here's Earth. Let's slow this down a bit. Let's slow down the time. So as we can see, it's now at 8 degrees and getting cold. So it looks like England there's pretty chilly. Got most of North America as well. Got all of like Northern Asia here, China, Russia, all in ice. Even a bit of Africa there had a bit of snow and ice on it, and then Antarctica as well. Not really much going on down there. So yeah, let's continue to keep this going, see if it cools down any more. So is Earth still habitable from this extra distance? So let's see actually how far away it is from the sun. So it is about 1.1 AU. That's pretty much the distance it is now. So yeah, slightly further away than usual, but can it handle it? So as long as the whole object doesn't become ice, we could probably still live here. As long as it doesn't get like below -10, we could probably live here still. So, but is it going to get cold? It looks like it is, and there we go. It's going to all freeze over now at all of the oceans. So this basically means if Earth was a little or 10% further away from the sun, we wouldn't be able to live here, I'd say, because yeah, all that's freezing up. We can see here all of Europe's like the United Kingdom, England's all connected to Europe now, North America's all connected as well. So all of the North is connected together, and Antarctica is very big now. As we can see, it's connecting to South America there. We've also got it connecting to, I think, Australia over here maybe. Okay, not Australia yet, almost there. Yeah, as we can see, we'll continue to keep this going. So yeah, Earth is getting chilly. Let's see how Venus is doing. Venus should have cooled down a bit. 441 there, not really. I don't think a small distance increase would make Venus too cold. I think by the distance of where Mars was originally, that should make it cool down a bit. But Mercury, that's how you're doing. So 100 degrees, okay, so Mercury is also getting pretty chilly, so it usually should be a little hotter than that. And I still really like the new texture actually they added. It's pretty good. Alright, anyways, I'm actually still hoping them to add custom gas giant colours into Universe Sandbox, because that'd be awesome, because we can change rocky planet colours but not gas giants. Alright, let's see how Mars is doing. So Mars, -59, so Mars is about 8 degrees colder than usual, so not too much of a change at Mars because its atmosphere doesn't really get it much heat anyway. Then we won't care much about Ceres and stuff because Ceres reflects a lot of light anyway, so it wouldn't really reflect it. Wait, hang on, that's not right. 0.00, I think it's like, it should be in the 90s, I think that's wrong. I don't know why it's that, or absorbing all the light, that's wrong. Should need to change that actually. Right, anyways, Jupiter, how are you doing? -166, that's definitely colder than usual. Saturn, 191, Uranus is 215, -215, Neptune is 226, and Neptune's pretty cold now, and Pluto, -233, so yeah, completely too cold for us humans. We've also got Sedna here, -251, so that is freezing. We've got Planet 9, -266, so that is almost completely absolute zero. And Planet 9 is even further out than usual, so 400 astronomical units almost. That is pretty far, or around 400. I didn't see the actual number. Right, anyways, let's speed this up a bit more. Just do let's do a few more years, just to make sure everything's working or doing properly. Anyone ever notice that Mercury's orbit also changes slightly as well? It's a permanent thing. It's not just me changing simulation. in real life, I believe Mercury's orbit is always changing. It's not changing size, but it's changing where it goes. So it's weird. Yeah, look, read out about it if you want. It's pretty hard to explain, but yeah. Maybe I'll do a video on it. Tell me if you want a video on Mercury's orbit, because probably won't be a long video, but it might be quite hard to do. But I should be able to pull it off. But anyways, we've got Earth here. Oh, 1 degree. Okay, Earth is just about suitable then. Actually, I'm wrong. No, we could probably live here at 1 degree, because yeah, there we are. So we must be in the summer sort of area here. There's England. There, I live here somewhere. Oh, that's too close. Dang it. Hey, what? Alright, there it is. Alright. Let's pause it. Oh, no. Pause. Yeah, I live somewhere here. Somewhere in the South England area. There you are. Alright, anyways. Let's speed this up a bit more. So it looks like Earth is fine at this distance. So 1.1 or 1.1 AU pretty much. We could probably just about survive on Earth here, which is pretty crazy. But anyways, next up we're going to go to powers again. We're going to press it again. So we're going to expand again. Make it even further away. So now, poor old Earth. Don't think it'll be able to handle this. So as we can see, it's definitely going to get a lot colder here. Yeah, minus 11 degrees now. And the whole thing is pretty much froze. Wait, is climate mode turned off? Turn that back on. How's that doing? But yeah, so now as we can see here, yeah, us humans probably wouldn't be doing pretty well now, because even the Sahara Desert, we got Death Valley in, like the hot place in America up here, near Los Angeles or Vegas, I think this place here. Somewhere here, this is very hot, along with the Sahara Desert. So yeah, but no one's probably been doing well, since this snow is probably very, very deep as well, if the whole Earth is pretty much a snowball now. So if we speed up a bit more, is the whole thing going to become a snow? Surely it will. Yeah, it looks like it is. And yeah, I think life on Earth would be pretty suffering right now, unless you've got extreme cold adaptation in like a creature or something. Adaptation, if we could adapt, but that would probably take generations. Yeah, I don't think us humans would survive. So yeah, poor old Earth is now pretty much a snowball. Bet that water there is still liquid, must be freezing cold. Right, let's see how Venus is doing as well, because we don't really need to care about the outer planets because they're already cold. So yeah. Right, anyways, Venus, okay, 409. Okay, it is decreasing. How's Mercury as well? So how far is Mercury from the sun here? Let's have a look. Okay, so how many AU is that? Right, no, that's not the one I want. AU, that's it. Okay, so 0.4. So yeah, Mercury's still pretty close to the sun. So that's interesting. Okay, how's Mars doing as well? Mars. Okay, so yeah, Mars is getting a lot colder as well. So let's actually go to Neptune here. I want to see, does Neptune still receive daylight or not? Oh, it's very dark here. Wow, look at that. So yeah, Neptune is pretty much almost completely dark. So that means Pluto probably is the same as well. So let's have a look. Yeah, Pluto's very dark as well, but that must mean if these guys are really dark, any object further than Pluto or is probably going to be frozen or completely disappear. So let's go to Make here, or Make, or yeah, I think that's how the Americans say it. Alright, so yeah, oh no, this still does have daylight actually. Okay, so what's further than that? Okay, Eris, let's try this one. Surely this is in darkness. Are we right? No, it has got very, very dim daylight, but if we look at the sun is like any other star in the night sky. So yeah, Eris probably is not getting much energy from it at all. And it does reflect quite a bit of light as well, 64%. Yeah, so this object here, surely this is in darkness. This 2013 FY27. No, that's in light as well. I don't know how these guys are receiving light from that distance. Like, surely you wouldn't. Okay, what about this one here? I thought I could enter, it should make me go faster. And that's that. I don't think that's right. Surely there's no way. Sedna shouldn't have daylight on it. I don't think. And Planet 9 shouldn't either. Okay, so yeah, that's what it should be like. Yeah, Sedna's complete darkness, and that means Planet 9 is obviously going to be the same, since Planet 9 is further away than Sedna at its current position. So yeah, there we go. So at least those guys are right. So let's go back to Earth now. So Earth, how are you doing? Minus 70. Okay, that is how far away from the sun? 1.21. So last time it was at 110% or just 10% more than usual. Now it's at 21% more than usual, and it's completely frozen. So that just means that if Earth was just slightly further away, we wouldn't be able to live here. So that just proves how lucky we are. to like where Earth is in its orbit. Because if it is a little closer, it'd be too hot, and if it was a little further away, like I just proved in the previous one before I made it bigger again, or made the orbits bigger, we could barely handle living there. So yeah, Earth's orbit is very lucky in the location where it is. It's still in the green zone here, but doesn't seem to be working. So yeah, Earth's a little too chilly, a little too cold. So let's continue speeding this up just to make sure. Okay, so it's below 0 permanently now. So yeah, poor Earth. Poor Earth is very done now. Anyway, let's check out on Venus. How cold is Venus? So okay, Venus is still in the 400s. Okay, so now what we're going to do is we're going to do it again. Right, no, I don't want that one. Close that. Okay, well, I have 2 options open at once. I didn't know you could do that. Alright, anyways, so we're going to expand again. We're going to see how cold it gets now. So the Earth's going into -40. So Earth here is almost as, or is pretty much now as cold as Mars would normally be at its normal orbit. So is Earth at Mars's orbit though? I think it is. The 1.33. I think Mars is around that sort of distance. The asteroid belt's been stretched out as well, which is pretty interesting. Because yeah, this would be the asteroid belt would have been stretched. I should have added it in. Oh well. Right, anyways, Mars, you must be -100 almost. Okay, -80. All right. Venus. See how you're doing as well. 300. So Venus is slowly cooling down. How's Mercury? Mercury is all going below 100 degrees. So Mercury is cooling down a lot. Eventually, just become a frozen ice body. Or maybe not ice, since I don't know if there's any water on Mercury. There may be water in its very, very thin atmosphere, or very, very low amount of water. But yeah, nothing we could probably see. But maybe it'll become an ice dwarf, or a dwarf planet, I should say. But it's still large enough to be a planet. So yeah, just be a cold planet. But yeah. All right. Anyways, so Earth. All right, Earth is completely finished now. So we're gonna go a little more insane here, and we're gonna double it. So we're gonna go to. We're going to press expand system twice. So there we are. So now Mercury should be as far as Earth normally is now. Let's have a look. Okay, so Mercury, let's have a look. Oh no, it's still not the size of Earth's orbit yet. Let's see, AU. Okay, it's about halfway to how Earth normally is. That means Venus must be where Earth normally is. Okay, 300 degrees. How far away are you? You are... Okay, so even Venus is further away than Earth normally is. This is pretty much the position where Earth was when we first expanded the system, so that's pretty interesting. Alright, Earth, 1.61 AU now. You're just completely too cold. Yeah, -50. Temperature of Mars on Earth. Yeah, we're all dead by now. Right, anyways, let's go to Mars. Okay, Mars is below -100 now. Or, yeah, -100 I should say. So now, we're going to continually expand and expand, and as we can see, the Sun is now orbiting something. I don't know what it's orbiting, but I don't know why it's doing that. Is it with Planet 9 maybe? Why has the Sun got an orbit? What is the Sun even orbiting? That's pretty weird. Let's see what it's... Is there any option here that tells us what its parental body is maybe? Oh, strongest attractor is Jupiter, but the orbit parent is Planet 9. I don't know how that works, because Planet 9 is only the mass of 10 Earths. Maybe it's just because it's so far away maybe. So Planet 9 does have an effect on the Sun, which is pretty interesting. And also Jupiter does as well. That's pretty weird, actually. But Planet 9 isn't the parent. How can it be? It's so much lower in mass. That's weird. So what's Planet 9's parent? The Sun? Oh, it is the Sun. See, the Sun is still the strongest attractor at this distance. And I think just to make things interesting, we'll add Alpha Centauri A in. And we'll put it 4.37... Is it? Yeah, 4.37 light years away. Just to see if eventually we expand it so much that... we expand it so much that the orbits will eventually get taken over by Alpha Centauri. So that'd be pretty interesting. So, what is it? Let me just quickly check this out. So, yeah, just bear with me here. So, Alpha Centauri. How far away is it? 4.37, isn't it? Oh yeah, 4.37. Alright, I was right. Right. So, 4.37 light years. It's about 4.37. So you would be about. Let's see, so Alpha Centauri would be that far away from the Sun. So we're going to expand this so large that hopefully Alpha Centauri will pick up some of the objects in the solar system. So that'll be pretty interesting. Alright, so we've got Earth now. How are you doing? Alright, so they're probably going to pull each other. Yeah, look, they're in like some weird orbit here. But remember that both of these objects will be orbiting a black hole as well. So yeah, this isn't truly realistic. But yeah, there we are. So how's Earth doing? So yeah, -119. Venus... 136 still. Okay, Mercury must be in the cold now. Yeah, minus 25. So Mercury is now cold. So the only warm planet left is Venus. So that's pretty interesting. So yeah, we're going to continue to expand this even more, since everything's already pretty much cold. Wait, actually, wait, hang on. Is it even working anymore? Let's go back to the sun. Let's just keep it paused. Expand system. Wait, nothing's happening. What the heck? Wait, maybe we have to delete Alpha Centauri. No, I want to keep that. Expand. Okay, there we go. So we can't have Alpha Centauri, sadly. Or maybe if we expand it so much that we can have Alpha Centauri added, because this solar system will be massive now. Alright, so now let's hit play. Oh, that sun orbit's gone. Thank God for that. Alright, so the sun's in the binary orbit with Jupiter now, okay? If you say so. So Mercury's in the minus 215s. Venus is minus 174. So yeah, Venus is not getting enough light anymore. So yeah, but wow, it's dark here. 52. So this is further away than like Neptune. This is double the distance of what Neptune's orbit normally is. So poor old Venus is just, yeah, not looking good now. So very, very dark there. So that means Earth. Damn, how are you doing, buddy? So Earth is minus 238. So that's completely freezing. 247 for Mars. How's Jupiter doing? Ceres 261. Jupiter minus 258. Saturn. Let's just go for Uranus. 264. So yeah, Uranus normally is the coldest planet in the solar system. We've got Neptune out here. 265. Oh, so Neptune is cold now. That's interesting. Probably because it's not getting any sunlight. So that kind of makes sense. Because Uranus maybe still getting sunlight. Are you getting sunlight or not? Let's have a look here. Oh yeah, so Uranus is still getting sunlight, but I'm assuming Neptune doesn't. That's why it's colder. Because yeah, Uranus I believe reflects more light than Neptune. Yeah, it does. It reflects 1% more. So that 1% makes a difference, obviously. Right. So yeah, let's see how Pluto is. Pluto, surely you're in darkness now. Let's have a look here. No, Pluto's still receiving light somehow. Okay, it's interesting. Okay, so let's see how far away Planet 9 is now. So, Planet 9 is 360 AU away. Oh, no, hang on, no. It's 52,000 AU away. That is enormous. So, a year on Planet 9 would take 12 million years. That's pretty crazy. 12 million years to go around the sun. That is humongous. Let's see how Sedna's doing. 6 million years. Let's go to Pluto here. How long does that take? Pluto takes, okay, 154,000, so 0.15 million years. See how these dwarf planets are? Okay, not in the millions. This one here, even this one's not in the millions. 0.7 millions, or 0.7 million years there. Okay, let's see how Earth is doing here. So Earth is normally 365 days, but now it is 622 years. So in days, that would be 227,098 days to go around the sun. So that's pretty crazy. Even Mercury, 133 years. That is just crazy. 26. So this is about the distance Neptune normally is from the sun. So if we go to Mercury here, very, very dark and yeah, scary here. So yeah, no warm planets anymore. But there we are. So looking good. Alright, so let's speed this up. We've done 20,000 years of simulation running now. That's pretty crazy. Right, so let's see how far away. How far away is Planet 9 at its furthest distance? So, Planet 9's furthest distance is a light year away. Okay, so if we continually... Let's put Planet 9 at its furthest point. So, we're going to go all the way over here, pretty much. So, wow, that's far away. So, yeah, this is going to be complete darkness here. But if we have a little look... Okay, I don't want to use that. Okay, so let's just use this one for an example. So, I'm put it in orbit. So, let's go around the sun here. So... 1.1 light years. So if we continually, expand a bit more, this should be able to, Alpha Centauri, if we add it in, should be able to take this over. So yeah, it's 2 AU now. Okay, 2 AU, so let's continually do it. So expand just a bit more. Let's just try now. So 3.2 light years. So that means if we added Alpha Centauri over here, I reckon it would take over Planet 9 and take its orbit. That's pretty interesting. Okay, so now let's hit play. Let's see how far away these guys are. That must be pretty crazy. Okay, so Mercury, closest object to the sun now, which is very, very far away, as we can see here. So let's turn all this. The sun is just like any other star in the night sky now. Oh, Excuse me there, I just had a little bit of a burp. Alright, anyway, so yeah, so Mercury is now completely in darkness, so that means all of the other objects are as well, but there's still hiccups, I mean, not burps. Yeah, so Mercury, like all the other planets, completely in darkness now, so what we want to do is we're going to just spam the expand button now, so I'm going to go to powers, oh no, is it, tools, not powers. Yeah, is that tools? Oh yeah, tools. Okay, so then we're going to do this. I swear that used to be called powers. They changed it. That definitely used to be called powers. I'm sure it did. Alright, anyways. So we're going to expand a little more. We're going to spam it. Just clicked it like 10 times. Now these orbits are going to be absolutely enormous. So Planet 9 is over 7 light years away. So what we're going to do is we're going to add Alpha Centauri A in at 4.37 light years away. So from the Sun. So 4.37. So that is 4.37, just a little bit more, 3.5, 3.7, so there. Alpha Centauri would be there if we expanded the system this much, and now that means Planet 9, from its furthest distance from the Sun, is now in orbit of Alpha Centauri A. Even though there it is. So there it is, there's this bad boy right here. Don't really use this much, but there we go. Alpha Centauri A, so we've got the rest of the solar system now. Doesn't look like Alpha Centauri can take these planets over yet, so let's delete that again. Well, look how big Planet 9's orbit is, that's massive. So we're travelling at 3,000 years a second here, look at this, it's crazy. The simulation can't run any faster. Alright, so if we expand it a little more, we'll keep an eye out on some of these. So let's just use Haumea for example. So this is, we want to get this to a light year away, so if we expand a bit more. Okay, so we need to get it up to about 4 light years away. So 5, yeah, that's 7, that'll work. So now if we put Alpha Centauri in, it's probably going to take over a lot of these objects, because Alpha Centauri is got a bit more mass than the Sun, which means, oh, we can put it all the way here, that's how far away they are. So 4.37 light years is right about here. So if we expanded the solar system this much, and we would eventually get so close to Alpha Centauri that Alpha Centauri would take over the orbits of some of the planets. So this is going to get pretty interesting now. So all these guys in here, they're just completely frozen. Venus minus 256, no longer hot. How's where's Earth at? How cold are you now? Earth, where are you at? At labels, there we go. So Earth is minus 268, so completely freezing. No one could live there. Alpha Centauri A. So yeah, Alpha Centauri has actually stolen some of the orbits around the around the Sun here. So that's pretty interesting. But we sadly can't speed the simulation up anymore, which does suck. But yeah, there you go. So we'll probably get an outcome like this. So 2 star systems would pretty much collide if we expanded the solar system so much that Alpha Centauri would eventually take some of the planets, or the dwarf planets. But even if we expanded it even more and more, they'd be so far away from each other, all the objects, that other stars or the Milky Way black hole itself, Sagittarius A, would eventually just pull all the objects apart and separate them and put them in different systems. So yeah, that's our conclusion there. So basically, conclusion: if we expanded the solar system over and over and over again, the solar system would start to break apart and lose objects because other stars would eventually take over. So yeah, there we go. So hopefully you guys all enjoyed this video, and if you did, make sure you hit that like button. Let's see if we can beat 20 likes in a day, because that'd be pretty cool. And also make sure to subscribe, help us on the journey to 900 subscribers. I've also got a special video coming out tomorrow for my 1-year anniversary, so yeah, stay tuned for that. And yeah, make sure you have a good day, and I'll see you in the next video. Goodbye. Yeah. Anyways, let's get into this. So I've actually forgotten how to do this. It's in, I think it's in powers. It should be here somewhere. Yeah, last time I did shrink. Today we're going to expand. So we're in my custom solar system as usual. We'll put the orbits on so we can see everything. So we've got Planet 9, Sedna, all of my customized objects, all in the proper orbits. All loads of extra asteroid objects around here as well. So we're going to go and expand and press it once. So I think that increases. I don't know how much it increases it by, but now all of the objects are a little further away. So that should mean that objects like Earth, for instance, are going to start to cool down a bit. So here's Earth. Let's slow this down a bit. Let's slow down the time. So as we can see, it's now at 8 degrees and getting cold. So it looks like England there's pretty chilly. Got most of North America as well. Got all of like Northern Asia here, China, Russia, all in ice. Even a bit of what's it, Africa there had a bit of snow and ice on it, and then Antarctica as well. Not really much going on down there. So yeah, let's continue to keep this going, see if it cools down any more. So is Earth still habitable from this? Hello everyone and welcome back to another Universe Sandbox 2 video, and today we're actually going to do an idea which a lot of people wanted me to do for a while actually. So I remember it was way back when I made a video on about shrinking the solar system. People also told me to expand it, which I never ever got around to doing. So today I thought I'd go back and actually go and do it. Because a lot of people did want me to do it like a long time ago, and they still, I know there was a person who said the other day they wanted it, so yeah, I'm going to go ahead and do it because a lot of people want it, so your wish is my command, I guess. So yeah, let's do this. And also guys, many thanks to the likes on yesterday's video. We hit 20 likes in a day, that's pretty awesome. So yeah, many thanks. Let's see if we can beat it maybe, I don't know. Anyways, let's get into this. And also it's the 1st of August tomorrow, which means I've been on YouTube for a year now, so there'll be a special cool video coming out which should do or should be pretty good, and you should enjoy it. An updated version of a video I made a very long time ago last year. So yeah, if anyone can work it out, yeah, comment below if you know. So extra distance. So let's see actually how far away it is from the sun. So it is about 1.1 AU. That's pretty much the distance it is now. So yeah, slightly far away than usual, but can it handle it? So as long as the whole object doesn't become ice, we could probably still live here. As long as it doesn't get to, like below -10, we could probably live here still. So, but is it going to get cold? It looks like it is, and there we go. It's going to all freeze over now, all of the oceans. So this basically means if Earth was a little or 10% further